All right, Chapter 4, Lesson 4. This is on linear functions. I kind of view this lesson as almost a review of some things that we've done before with just a little bit new terminology mixed in. So we've had functions before. We've had linear equations before. You've graphed them using slope-intercept method, starting at the y-intercept and going up or down according to whatever the slope says. So this really isn't much different. This teaches you a different way of doing the chart. I think the chart is a lot more tedious, and I would just prefer to do it slope-intercept method. But I'm going to teach it to you, and you can choose the method that you wish. Choose whichever one you think is better. So, looking at example 1, it says the school store sells book covers for $2 each and notebooks for $1. Tony has $5 to spend. The function y equals 5 minus 2x represents the number of book covers x and notebooks y she can buy. So in other words, she can only buy as many notebooks as her $5 minus the amount that she spends on book covers will allow her. So that's what this equation means. Graph the function and interpret the points graph. Now, if it were me, I would write this in slope-intercept form, which is, of course, y by itself, and then just switch these two. So minus 2x plus 5. I would start on 5 and then go down 2 over 1, down 2 over 1, down 2 over 1. But that's just me. They would have you choosing domain points for x, putting it in the chart like we learned last lesson, and find out how many y's this is. Now, here's the advantage to this that I see, and this is probably the only advantage to this that I see. We said that x were book covers and y was notebooks. So the only advantage to this I see that what if she buys 0 notebooks, then she could, 0 book covers, she could buy 5 notebooks. If she only bought 1 book cover, she could buy 3 notebooks. If she only bought 2 book covers, she would buy 1. But if she bought 3, she wouldn't be able to buy any because there's not enough left over for her to buy that. Okay, she'd be minus $1. So that's the thing that I see whenever it says graph the function, which we can do either way, but then interpret the points graphed. When you interpret the points graphed, that's what it's asking you to do. It's wanting you to say right here, she cannot buy negative amounts, obviously. So she could buy 0 book covers and 5 notebooks. That's what that one is. 1 cover and 3 notebooks, or 2 book covers and 1 notebook. Those are her options. All right. So I want you to try this next one. You try this next one. And just a little far. You try. Come on. Being difficult today, are we? Usually only happens when we're right at the end of the page. I have figured that much out. Yep, see? Go one too far, and that's what happens. And then it goes back again. Good night. I'm not going all the way to the bottom. You've got your page. You can figure that part out. All right. Pause it and try the got it. All right, back with me. The farmer's market sells apples for $2 per pound and oranges for $1 per pound. Marjorie has $10 to spend. The function y equals 10 minus 2x. This is her $10 minus the $2 per pound of oranges. That's how many apples she can buy. Represents the number of apples, x, and oranges, y, that Marjorie can purchase. Graph the function and interpret the points graphed. So, where am I at? Oh, right there. All right. So we've got a table, if you wish. So x, y. It says graph the function. You don't have to always do 4. I say that there's a minimum of 3. So if you want to pick 3 numbers and graph them. So if you put in a 2 for x, 10 minus 4. Put in a 2 for x. 10 minus 4, 6. If we put a 1 in right there, 10 minus 2, 8. And of course, if it's a 0, that whole part's gone, and it's just a 10. So if we graph that, we could do 2, 6, 1, which would be kind of right here in the middle, 1, 8, or 0, 10. That's your line. Okay, that's your line. And again, I know I always tell you to use rulers, but it's kind of hard to use a ruler on a board like that. So interpret that. What does that mean? Well, we said that apples are X and oranges are Y. So what if she buys 10 oranges, then she can buy 0 pounds of apples. If she buys 8 pounds of oranges, she could buy 1 pound of apples. If she bought 6 pounds of oranges, 2 pounds of apples. Okay? That's what that means. And you could even, I mean, those pairs will go all the way down. So even like right here, if she bought 5 pounds of apples, which are $2 a piece, she could buy 0 oranges. So you just have to write out my combinations, kind of like this right here. Okay? So that's what that means. And not everyone's going to pick the same numbers here, but they are all going to be pairs that are on that line. All right? They're all going to be pairs on that line. So with that, we are moving on. Now let's go to the next page. So again, this talks about graphing those lines. I would not mess with the chart if it were me. If it were me, I would just go straight to, it says that the y-intercept, we know that this number right here represents the y-intercept, which is 2. I would come right there and do a 2. And then I know that the slope is 1, which is 1 over 1. So from here, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. It gives me these points right here. But whenever it says make the chart and then talk about each one, if you had to interpret it, if they gave you one to interpret, you could say, okay, when you bought 0 of these, you could get 2 of these. But this one, it doesn't. It doesn't say do anything like that. It just says graph that. So if it were me, I wouldn't worry about doing this whole chart, which is just extra work. I would start right from the slope-intercept, from the y-intercept, and do the slope-intercept form. All right? So looking down at the next one. If I were to graph this, again, you can make the chart if you wish, or you could use our prior knowledge and just say, okay, the y-intercept is -5, 1, 2, 3, 4, 5. Slope is 1, means I'm going to go up 1 over 1, up over, up over, up over, up over. That is my line. This one, y equals -2x. If it does not have a slope-intercept, then actually it takes this formation, right? That form of an equation. So that is a direct variation, which you know always goes through the center. But if it does not have a if it does not have a y-intercept, you assume it's a 0 anyway. So this tells us that you're going to go down to, make that a fraction, go down 2 over 1, down 2 over 1. And if you want to reverse it to go up this way, you can do that. That is my line. Make sure you're putting arrows at the ends of your line, by the way. I've noticed some people are not, so just make sure that you are. Okay? And with that, here comes the new terminology that we're talking about. So, whenever you talk about representing linear functions, we talk about words, all right? The value of y is 1 less than the corresponding value of x. Sounds real mathematical, but it just means that y equals x minus 1, all right? So that's our equation. You could do it in a table, you could do it in a graph, you could do it in ordered pairs, and get the domain and range, that kind of thing. So there's all kinds of information you could take from that, a lot of useful information. So as we've learned before, a linear function is just a function where the graph is a straight line. So that's where we get our y equals mx plus b. Now, here is your new information, your new vocab that I want you to pay careful attention to. And these examples that they have on here are actually pretty good examples. So a function can be considered continuous or discrete. So think just for a minute about what continuous means. It means it keeps going. There's no breaks in it. If it were going to rain continuously, that means it would rain and rain and rain, like 40 days, 40 nights, that type thing, and nothing, it would never stop. So that could take on any value. They could be fractions, decimals, little bitty fractions, way big decimals, whatever you want to call them. But there's no breaks in it. Discrete data means that it only happens for certain amounts, kind of like our jars of peanut butter that we had on the last lesson. You cannot buy a jar of peanut butter. And if you saw a jar of peanut butter on the store shelf, half empty, half full, depending on what kind of person you are, I would not want to buy that. I don't know about you, but I would not. So continuous data, look at these examples. Continuous data, the number of ounces in a glass. So whenever you pour water in a glass, can you only pour exact ounces? No. You could pour an 8-ounce glass. You could pour 8.2. You could do 7.95. It's going to be close. Discrete, how many glasses can you fit in your cabinet? It talks about a cupboard, but how many glasses can you fit in your cabinet? Do you store 0.2, 9, 5, 6, 7, 8 glasses? No. The weight of each chocolate chip, depending on how big the chocolate chip is. Sometimes around Valentine's Day, you get those monster chocolate Hershey's Kisses. Big chocolate chips. Now, how many chocolate chips could you fit in a bag? Well, I know there's always a possibility of like half a chip, something breaking off, something like that. But they don't purposefully put half chips in there. All right, so that would be discrete. Things that could only be certain amounts, like only whole numbers. So there would be breaks in your graph. Those would not be lines. All right. So it talks about continuous. That would be a solid line, just like what we've jotted so far. In discrete data, you would just have dots. So this, something that looks like this, your axis, this would be continuous data, right? There's no dots in here. If I were doing discrete data, means that like I could only have 1 glass, 2 glass, 3 glass, 4 glasses, that kind of thing. There would be holes in it. There would just be dots. All right. So let's try an example of this. Each person that enters a store receives a coupon for $5 off his or her purchase. So write a function to represent the total value of the coupons. That's where this y equals 5x. So the value of the coupons, y, depends on how many $5 coupons you give to how many people. Okay, so that's what we're talking about. If it says graph it, time out again. All right, if it says graph it, you have to make your points, right? 5, 10, 15, 20 customers. Multiply each one of them. This is the value of the coupon. So if I were going to graph it, notice that the graph of this is not a line. The graph of this is just dots. There can only be whole number amounts of customers. You're not going to give a $5 customer to 2 2/3 customers. Sorry, $5 coupon to 2 2/3 customers. So that's why this is discrete data. You cannot have partial customers. All right? So under got it, a store sells nuts for $5.95 per pound. Write a function. Well, that's going to be y equals 5.95x. Complete the function below for the cost of 1, 2, 3, 4, or 5. So you're going to take 1, 2, 3, 4, or 5. Come on. 1, 2, 3, 4, 5 pounds of nuts. And you're going to take them times 5.95. So you're going to do that multiplication all the way down. 2 times 5.95 all the way down. Okay? So that's what you've got. And then whenever you graph it, is this continuous or is this discrete? Is this continuous or is it discrete? Now, if I were going to do this out, I would have 1 at 5.95. So I'm going to put a dot right about here. Come on, pen. 1, 5.95. Now, 2, I know it's going to be 11.90 if I were going to do my multiplication out there. But now think about this. Can you only buy your assorted nuts by the pound? Like, think about going to Walmart. Do you only get like so many at the deli? If they are going to do this, if you're going to buy a pound of turkey, well, they're not going to stop at exactly 1.00. Sometimes it's a little bit more than that. So it is continuous, right? You could have 0.999. They're not going to worry about giving you an extra little pinch. So that is continuous. All right, so I just want you to experiment with these, see what you got. As always, ask me questions if you have them. Good luck.